Good morning, grade sixes, and welcome to WorksheetCloud. I'm Mrs. Hall, and I look forward to teaching you your lesson today. I hope you guys had a good weekend and you enjoyed the long weekend. Remember, it's only a 3-day week ahead of you, so that means on Friday you get another day of rest. Today's lesson, grade sixes, is on static and current electricity. So our objectives for today are as follows. What is electricity? We're going to look at static electricity, current electricity, sources of energy, conducting material, devices, as well as open and closed circuits. Right, let's start with what is electricity. So electricity is a form of energy. It is energy. It is all around us. We get different kinds of electricity. We're going to speak today about static electricity as well as current electricity. So static electricity exists when there is a buildup of opposite charges on objects separated by an insulator. Now, this is a follow-on from lesson 1, so you should have all your prior knowledge to prepare you for this lesson. If you haven't watched lesson 1 yet, please do that before continuing with lesson 2. So, static means as in at rest. It is electricity that exists until the two groups of opposite charges can find a path between each other to balance the system out. So opposite charges with an insulator between them. Right, so one of the most dramatic examples of static discharge is lightning. And I'm going to put a picture up and you can follow on the picture as I explain to you. So when a cloud system gathers enough charge relative to either another group of clouds or the Earth's ground, the charges will try to equalize. And as the cloud discharges the massive quantities of positive or sometimes even negative charges, these charges run through the air from the ground to the cloud, causing a visible effect we all are familiar with, and it creates a lightning flash. So the negative charges are attracted to the positive charges on the ground and a lightning flash occurs. Okay. Static electricity also exists when we rub balloons on our head. Okay, there you go. Look at that picture of a little bubba. I couldn't resist. Okay. Sometimes it makes our hair stand on end, or sometimes when we shuffle on the floor with fuzzy slippers and then you go and you touch an object, like sometimes a family cat, accidentally of course, and it creates a shock. In each case, friction from rubbing different types of materials transfers the electrons, and we spoke about how those electrons move in our last lesson. The object losing the electrons obviously now becomes more positively charged, while the object gaining electrons becomes more negatively charged. And then the two objects become attracted to each other until they find a way to equalize. And isn't that a cute little pic there? Sometimes electrostatic charges can build up on a cat's fur, giving off sparks when stroked. Okay. So let's take a look now at current electricity. So current electricity is the form of electricity which makes all of our electronic gizmos possible. This form of electricity exists when charges are able to constantly flow, as opposed to static electricity, where charges gather and remain at rest. Static at rest. Current electricity is dynamic. The charges are always on the move. Did you know that current electricity is measured in amperes or amps, which is named after the French scientist, there you see him over there, André-Marie Ampère. I hope I pronounced that correctly. I'm not French, so sorry if there are any French people watching. Current electricity, we use current electricity to power our televisions, our lights, our computers, and all of our other appliances. Current electricity is the constant flow of electricity from a positively charged site or place to a negatively charged site. The electricity is generated in a power station and travels to a building via wires. And we will be looking at mains electricity in a lot more detail in a couple of lessons. So when you plug an appliance into a socket in the wall, current electricity makes the appliance work. So let's take a look at the sources of energy now. Okay, so batteries are common energy sources which convert chemical energy to electrical energy. So a chemical reaction takes place inside the battery. They have two terminals which connect to the rest of the circuit, the positive and the negative. So batteries, a battery stores its energy, which is charged into electricity when the battery is in use. And that's a common battery that you should all recognize. In the 1800s, an Italian scientist named Alessandro Volta built the very first battery, and it was called a voltaic pile. And how did he make it? So he built it by stacking layers of copper, zinc, and cloth soaked in salt water. The force at which an electric current is pushed around a circuit is measured in volts. Okay. And most types of batteries measure between 1 and 12 volts. The mains electricity in your house in South Africa is 230 volts. So, that was talking about batteries. Let's have a quick look at mains electricity, which comes from the power station. So mains electricity is a general purpose, alternating current electric power supply. It is the form of electrical power that is delivered to our homes and businesses. And it is the form of electrical power that consumers use when they plug items, like I said earlier, all of our appliances, our televisions, and our electric lamps into the wall outlets. Okay, so when we look at electricity in a few lessons further down the line, we're going to look at how the electricity comes from the national grid into our homes. Okay, so how it's transported through the country along the national grid and into our homes. We connect to the mains, obviously, by plugging into our appliances. Be careful not to plug yourself in. Okay, and we will look at that when we look at electrical safety. So just to recap, two main types of electricity, mains, okay, and battery electricity. Okay. So what kind of electricity do the following appliances use? Would this calculator use mains or a battery? It would use a battery. This fridge, would it use mains or battery? We have to plug it into our wall socket, so it would use mains electricity. Over here we have a little game, a little Wii game. What would it use? Do we plug it into our wall sockets? No, it has batteries. So it is, the source of energy here would be batteries. Microwave, we plug into a wall socket, so it comes from mains electricity. And over here is our computer, and yes, we plug it into the wall socket, so the battery inside the computer is charged from mains electricity. So now let's take a look at electrical circuit components. So in order to flow, current electricity requires a circuit, which is a closed, never-ending loop of conductive material. A circuit could be as simple as a conductive wire connected end to end, but useful circuits usually contain a mix of wire as well as other components which control the flow of electricity. So over here we have our batteries, we have our positive side of our battery as well as our negative side over there. So electricity flows along a path called the circuit. A circuit is a loop of wire leading from a power source to an appliance and back to the power source again. A battery has two connection points, a positive and a negative. And electricity flows from the negative to the positive connection point. And then very important when we start looking at circuit diagrams, what we have here is a single cell. This is the correct scientific diagram for a single cell. That is the negative. That is the positive. That is one cell on its own. When you have two cells connected, as in this scientific diagram over here, it becomes a battery. Okay. And you will learn about this more when we start drawing our circuit diagrams. So our conducting material over here are the wires. Those are the conducting materials that carry the electrical current from the energy source, okay, to the other parts of the electric circuits. And an electric current is the movement of the electrical charges through a conductor. And like I said earlier, from the negative to the positive. So that would be the direction of the electron flow. So just to recap, this is a conductor. It's copper, very good conductor of electricity. The plastic surrounding it is an insulator, which does not allow electricity to flow through it. Otherwise, we would get an electric shock. Let's look at our devices. They are also called output devices. These are man-made objects and they are made to do a specific job. So different devices are used in electrical circuits to convert or change electrical energy to other forms of energy, such as light, such as sound or movement. Okay, so bulbs, buzzers and motors are examples of devices. They are output devices if we are using the correct scientific terminology. So one of our first output devices we're going to look at is a bulb, and it changes electrical energy into light energy. Now, Edison was a scientist who patented the first incandescent light bulb, which refers to a bulb with a filament that heats up to emit the light. Okay, and that filament is made out of an element called tungsten, and you will learn about the elements of the periodic table next year. Okay, so that's an incandescent light. We get different kinds of lights. We get fluorescent light bulbs. Now, fluorescent lamps are far more efficient than an incandescent light and only give off a quarter of the amount of heat of an incandescent light. Okay, they're generally called energy saving light bulbs, and they also last longer. Okay, we then have the LED light, which stands for light emitting diode. Okay, an LED is made like electronics. It is a chip of semiconducting material. Okay, LED bulbs are more efficient and last much longer than either incandescent or fluorescent light bulbs. Unlike fluorescent bulbs, LEDs do not use mercury, which is very toxic. Just a little bit of general knowledge for you. Until recently, LED bulbs were not as bright as the other kinds of lights, and they cost more too. But that's all changing now as technology progresses. And here you can see the LED lights that you can recognize now. Okay, buzzers is another output device. It is an electronic device that makes a buzzing sound. It converts the electrical energy into sound energy, and that's what it looks like. And you would connect that to a circuit if you were doing a practical at school, and you would get a buzzing sound. Okay, there's your normal doorbell. Motors. Electric motors convert electrical energy into movement energy, so energy that is able to move. Electric current passes through a motor, causing the shaft to spin. Now, obviously, motors come in very different sizes, okay? Obviously, you're going to have a very large one in a washing machine for that motor to spin your washing, to clean it and to rinse it and then to get rid of the water. It has to be quite a large motor. Electric motors are commonly found in household appliances such as fans and washing machines. Here you have your fan. Sorry, I just need to go back there. Let me go back. Previous, okay, such as fans and washing machines, and the spinning movement can be used in many different ways. And I just wanted to show you the fan there. It has a motor in it that spins the blade that gives off cool air. Okay. Right, then we have switches. Now switches, another device used in electrical circuits. Electricity is not able to move through a circuit if it is broken in any way. So a switch is added to a circuit. The switch is used to start or stop the flow of electric current in a circuit. So when it's on and when it's off, when it's on, it allows the flow of electrons. When it's off, it doesn't. This is useful when you want to turn an appliance on, like your lights, okay, or your plug socket point, okay, and even your stove over here works with switches which are on, which allows the electricity to flow or not flow, okay. And it helps because it helps the appliance. You won't have to actually plug it in or unplug it all the time. You just use a switch to switch it on or off. Right, open and closed circuits. For electrical current to flow, it needs a complete unbroken pathway. As you can see over here, it is a closed circuit, okay? And that allows the light bulb to shine. This means there can be no gaps between the parts of an electrical circuit. If there is a gap, like over here, then the electrons cannot flow, and we say the circuit is broken and the light bulb will not glow. Right, a little bit of a quiz for you. Let's check out your general knowledge, just general everyday knowledge, and what you've learned today. Okay, so electricity is a form of energy. Is that true or false? It is true. Electricity travels at the speed of light. So in other words, more than 186,000 miles per second. True or false, grade 6s? True. Okay. A bolt of lightning lasts at least 10 seconds. Do you think that's true or false? It's false. Okay. Go and do some research on lightning. Very interesting. Electricity always needs a power source to work. Is that true or false? It's true. And we spoke about our different power sources, our batteries or our mains electricity. Now, electricity can be made from lots of different sources of energy. Example, wind, water, and solar. Do you think that's true or false? It's true. And we're going to be taking a greater look at that in a lot more detail when we speak about power stations and sources of energy to the power stations. And an open circuit will light a bulb. True or false? It is false. Okay, that means there is a gap. It needs to be a closed circuit. Right. Grade 6s, I hope you enjoyed this lesson. Thanks for watching. I am trying to break this down into bite-sized chunks of information for you and not overload you with too much information. For those of you that love science and you've gone ahead, great. But we're also trying to reach the children that are not able to move ahead as quickly as what all of us are. So I'm breaking it down into bite-sized chunks so that you can use the information I give you to consolidate and recap and revise from previous knowledge. So in my next lesson, which will be tomorrow, my lesson 3 on electricity, we will be looking at scientific diagrams with circuit diagrams and all the different components that we use in a circuit diagram. So grade 6s, please download the homework sheet. Please remember, if you can't answer all the questions, it's okay. It might only come out in my next lesson, the answers to those questions. So no pressure on yourselves. Remember, take it easy, breathe, relax, and enjoy the rest of your afternoon. Thanks for watching, grade 6s. I'll see you tomorrow.